For most of its time on Earth, the human species did not live long lives. Individuals were fragile, bodies broke easily, and death arrived early. Yet the species itself endured. While countless other human-like species appeared and vanished, this one remained, not because it was stronger or faster or better protected, but because it survived in a way that did not depend on long lives at all. Evolution did not preserve humans by making them last. It preserved them by allowing them to replace themselves. The strange truth is that the human species has existed for a very long time, even though most humans have not. Longevity at the level of the species was built on short, expendable lives. And this raises a quiet but unsettling question. What kind of survival was evolution truly selecting for? The length of time a species exists is often confused with the length of time its members live. But in biology, these are very different measures of survival. A species can persist for hundreds of thousands of years, even if each individual life within it is brief. The human species is a clear example of this separation. When we say that humans have existed for a very long time, we are not describing long human lives. We are describing an unbroken chain of reproduction, replacement, and continuity that stretches far beyond the lifespan of any single body. For most of human history, individual lives were short, uncertain, and fragile, yet the species itself continued without interruption. This endurance did not require long-lived individuals. It required only that enough individuals lived long enough to pass on their genes before dying. From the perspective of evolution, that was sufficient. Natural selection does not measure success by comfort, wisdom, or longevity. It measures success by continuation. A species survives not because its members endure, but because they are replaced. The human lineage followed this rule closely. Generation after generation appeared, reproduced, and disappeared, while the line itself remained intact. This is why the age of the species cannot be read from the age of its individuals. The two operate on different clocks. One is measured in decades, the other in millennia. Early humans lived in environments where injury, infection, hunger, and exposure were constant threats. Few reached what we would now consider old age. Yet these conditions did not threaten the survival of the species as long as reproduction occurred. In this sense, human survival was distributed across time rather than concentrated in long lives. The species advanced by moving forward quickly, not by staying alive longer. This distinction explains why human biology shows little evidence of being shaped for longevity beyond early adulthood. Many systems in the body function well when young and gradually degrade after reproduction is complete. From an evolutionary viewpoint, this decline was not a failure. It was simply irrelevant. The species had already succeeded by the time the individual body began to wear down. When we look at human history through this lens, the long existence of the species becomes less mysterious. Humans did not need to be durable, they needed to be sufficient. They needed to reach maturity, reproduce, and transmit their traits. Everything beyond that was optional from evolution's perspective. The persistence of the human species was therefore built on turnover, not preservation. The population survived because individuals were replaceable. This idea can feel unsettling because it conflicts with how modern humans value long life and accumulated experience. Today, survival is often associated with aging well and living longer. But for most of the species' existence, survival meant something quieter and more limited. It meant continuing the line, not extending the life. The deep history of humanity reflects this logic repeatedly. Long before medicine, sanitation, or stable food supplies, the species endured by accepting loss at the individual level. The human story is therefore not one of bodies lasting, but of continuity maintained through constant renewal. Understanding this difference helps explain how humans could exist for so long without evolving to live long lives. The species endured because time was carried forward by new generations, not held within old ones. The difference between individual lifespan and species lifespan becomes clearer when we look at the physical evidence left behind by early humans. Skeletal remains from prehistoric populations consistently show signs of early wear, injury, and disease. Teeth were often ground down at young ages. Bones show repeated fractures that healed imperfectly, and signs of chronic infection appear long before what we would now call old age. These bodies were not built to last for many decades. Yet these same remains also reveal repeated patterns of growth, reproduction, and replacement. Children survived often enough to become adults, and adults lived long enough to raise the next generation. That rhythm was all the species required. From an evolutionary standpoint, a population does not need elders. It needs continuity. The archaeological record quietly confirms this. Burial sites from different periods show high mortality in infancy and early adulthood, followed by a sharp drop in survival later on. Few individuals reached advanced age, but enough reached maturity. This pattern repeated itself across regions and climates, suggesting it was not a local failure but a stable condition of human existence. The species persisted because this balance held. When survival is viewed this way, longevity becomes a secondary trait. What mattered most was timing. Reproduction had to occur before the body failed. Human biology aligns closely with this requirement. Growth is rapid, sexual maturity arrives relatively early, and peak physical performance occurs well before midlife. After this window, maintenance becomes less precise. Cells repair damage less effectively, immune responses weaken, and tissues accumulate small failures. None of this would have threatened the survival of early human populations because the essential task had already been completed. The species had moved forward. This separation of clocks is important. The biological clock of the individual runs quickly, pushing toward reproduction and early survival. The clock of the species runs slowly, advancing one generation at a time. These clocks do not need to align. In fact, aligning them too closely could have been costly. Investing heavily in long-lived bodies would have required energy and resources that early humans did not have. In unstable environments, it was safer to produce more generations than to preserve aging ones. The species adapted to uncertainty by favoring renewal over endurance. This strategy also explains why human populations could recover after repeated losses. Famine, climate shifts, disease outbreaks, and conflict removed large numbers of individuals, yet the species did not collapse. As long as some survived to reproduce, the line continued. The loss of individuals, even many at once, did not erase the species. Evolution does not protect lives equally. It protects patterns that persist. The human pattern was not long survival but repeated return. Each generation restarted the experiment. Knowledge was passed imperfectly, bodies were rebuilt from scratch, and the same vulnerabilities appeared again and again. Still, the line endured. This is why the long existence of the human species does not imply biological success at the individual level. It implies a system that tolerated failure. The species accepted short lives, high risk, and constant loss because those costs did not interrupt continuation. Seen this way, the history of human survival is not a story of durability, but of repetition. Time was carried forward by new bodies, not stored in old ones. The species survived because it never depended on individuals lasting. It depended on the next beginning arriving before the final end. When the survival of a species is examined over deep time, it becomes clear that endurance does not require stability at the level of the individual. What matters is not how long a single human body lasts, but whether the chain connecting one generation to the next remains unbroken. In early human populations, this chain was often thin, but it was rarely severed. Small groups faced constant risk, yet even under harsh conditions, reproduction usually continued. This continuity was enough to carry the species forward. The idea that survival depends on long life is a modern intuition. For most of human existence, survival depended on overlap. One generation did not need to last long. It needed only to overlap briefly with the next. Parents did not have to grow old. They had to live just long enough for their children to survive infancy. Once that threshold was crossed, the species had already secured its future. This overlap created a rolling passage of time, where knowledge, behavior, and genetic material moved forward without accumulating in aging bodies. Each generation reset the biological clock, carrying the species through periods of instability that would have destroyed a population reliant on longevity. This pattern shaped how human societies functioned. Social structures emphasized cooperation among adults in their physical prime. Elders existed, but they were rare, and their presence was not essential for survival. Cultural memory was fragile, often lost and rebuilt. Tools, techniques, and traditions had to be rediscovered repeatedly. From a modern perspective, this seems inefficient, but from an evolutionary perspective, it was sufficient. The species did not need to preserve information perfectly. It needed to persist. This is another way in which individual durability was unnecessary. Even memory itself was replaceable. When groups disappeared, others formed. When knowledge vanished, it slowly returned. The species continued despite these losses. This tolerance for loss is a defining feature of human endurance. It explains why the human body shows little evidence of being designed for long-term maintenance. Systems responsible for repair and stability weaken after early adulthood. Bones lose density, organs lose resilience, and cellular damage accumulates. These changes are not accidents. They are consequences of limited investment beyond the reproductive years. Evolution did not remove these vulnerabilities because they did not prevent continuation. The species had already moved on. In this sense, aging was never a central problem for early humans. It was simply the background condition of a life that had already fulfilled its role. The persistence of the human species was therefore built on acceptance rather than resistance. It accepted that bodies would fail, that individuals would be lost, and that experience would often disappear with them. What remained was the line itself. Over time, this strategy proved remarkably effective. While many other human-like species appeared and vanished, Homo sapiens maintained its presence, not by outlasting death, but by arriving again and again. The long existence of the species is not evidence of exceptional bodies. It is evidence of a system that did not require them. Humans endured because survival was distributed across countless short lives, linked briefly but continuously. Time flowed forward through renewal, not preservation. This understanding reframes the question of why the human species has existed for so long. The answer is not found in strength, intelligence, or longevity alone. It is found in a quieter mechanism, the willingness of evolution to let individuals go, as long as the pattern continued. The species survived because it never depended on anyone staying. It depended on someone coming next. From the perspective of evolution, survival does not mean living long. It means lasting long enough. For early humans, this distinction defined the shape of life. Natural selection did not reward individuals who reached old age. It rewarded those who reached reproduction. Once that threshold was crossed, the biological task was complete. Everything beyond it carried little weight in determining whether the species continued. This principle explains much of human biology. Growth is prioritized early. Childhood is brief. Adolescence arrives quickly, and sexual maturity appears long before the body reaches peak stability. These are not accidents. They reflect an evolutionary focus on timing rather than durability. In environments filled with danger and uncertainty, waiting too long to reproduce was risky. Bodies could be lost suddenly to injury, infection, or hunger. Selection favored those who reproduced earlier, even if that meant bodies declined sooner afterward. The human species followed this path closely. For most of its existence, living long was unlikely. Living long enough was achievable. This difference mattered. Reproduction anchored the species in time. As long as new individuals entered the population before others disappeared, the line held. This created a biological minimum rather than a biological maximum. Humans were shaped to cross a lower boundary, not to extend an upper one. Once reproduction occurred, evolution largely withdrew its attention. Maintenance systems weakened, repair slowed, and vulnerability increased. These changes were not punished because they did not interrupt continuation. The species advanced regardless. This logic also shaped social patterns. Care was concentrated on the young, not the old. Energy was invested in growth, protection, and learning during early life. Later decline was accepted as normal and unavoidable. There was little evolutionary incentive to prevent it. From a modern viewpoint, this can seem harsh, but in deep time, it was efficient. Resources were scarce. Preserving aging bodies would have demanded energy that early human groups could not afford. It was safer to direct effort toward producing and supporting new life. This strategy allowed populations to persist even under repeated stress. When individuals died young, others took their place. The loss was real, but it did not threaten the species. This helps explain why the human body often feels unfinished. It performs remarkably well early on, then slowly unravels. Evolution did not correct this because there was no pressure to do so. Selection ends where reproduction ends. Beyond that point, decline carries little evolutionary cost. The human species existed for so long because it did not depend on long lives. It depended on reaching a narrow window and passing through it. That window was reproduction. Everything else was secondary. This understanding reframes the idea of success. Longevity was never the measure. Continuation was. Humans endured by meeting the minimum requirements of survival again and again. They did not need to be strong forever. They needed to last just long enough, often under difficult conditions, to ensure that the next generation arrived. This quiet efficiency carried the species forward across hundreds of thousands of years. The long existence of humanity rests not on extended life, but on precise timing. Evolution selected for crossing the threshold, not for staying beyond it. The emphasis on reproducing early shaped not only when humans lived, but how their bodies were organized. Many traits that define the human form make sense only when viewed through this narrow evolutionary window. Muscles, bones, and organs reach their strongest coordination relatively early in adulthood. Reaction time, strength, fertility, and healing all peak well before what modern societies consider midlife. After this period, decline begins gradually and then accelerates. From an evolutionary standpoint, this timing is logical. The body is optimized to perform well when reproduction is most likely. Once that phase passes, precision becomes less important. Maintenance shifts from priority to afterthought. This does not mean evolution designed humans to age. It means aging was never actively prevented. In early human environments, preventing aging offered little advantage. Few individuals lived long enough for late-life health to influence reproductive success. Selection pressure simply did not reach that far. This explains why many age-related problems appear consistently across populations and eras. Joint degeneration, reduced vision, metabolic imbalance, and weakened immunity are not modern diseases in origin. They are expressions of biological neglect beyond the reproductive window. Evolution did not invest in solving problems that appeared after the essential task was complete. The species continued regardless. This pattern also clarifies why lifespan extension is so uneven across the tree of life. Some animals evolve long lives because their survival strategy depends on extended reproduction, long parental care, or low predation. Humans followed a different path. Early humans reproduced while relatively young and relied on group cooperation rather than long individual endurance. Children were raised collectively, skills were learned quickly, and survival depended more on social structure than on the prolonged health of any one body. In such a system, long life was not required. What mattered was that enough adults were present at the right time. This logic even shaped human vulnerability. Risk-taking behaviors, physical stress, and exposure to danger were common because the evolutionary cost was limited. Losing individuals after reproduction did not threaten the population. As long as the cycle continued, losses were absorbed. This tolerance allowed the species to move quickly, adapt behaviorally, and spread into new environments without waiting for biological refinement. The body remained imperfect, but the pattern endured. From this perspective, the long existence of the human species was built on acceptance of limits rather than their removal. Evolution did not aim to perfect the human body across the entire lifespan. It aimed to push it reliably through a critical passage. Once that passage was crossed, the outcome for the individual mattered less. The species had already secured continuity. This understanding can feel unsettling because it contrasts sharply with modern values. Today, longevity is often equated with success. Aging well is seen as a goal, but for most of human history, aging itself was not a central concern. It was simply the phase that followed completion. Survival had already been achieved at the level that mattered most. The species existed for so long because it required very little from each life. It did not ask individuals to endure. It asked them to arrive, reproduce, and make way for the next. This minimal demand, repeated across countless generations, proved extraordinarily effective. Time moved forward, not through preservation, but through passage. Each life was a brief carrier of continuity, not its final destination. The human species endured by keeping its requirements low and its turnover high. In doing so, it crossed centuries without needing to conquer age itself. The focus on surviving just long enough also shaped how human populations responded to loss. Because reproduction occurred relatively early, death after that point did not disrupt the continuity of the species. This created a quiet resilience at the population level. Early human groups could absorb repeated losses without collapsing, because the essential process had already taken place. Children had been born, and the line moved forward even as individuals disappeared. This resilience was not emotional or moral. It was structural. The system did not depend on protecting every life. It depended on ensuring that enough lives crossed a single threshold. As a result, the human species became tolerant of instability. Drought, disease, violence, and migration removed people constantly, yet the species endured. This tolerance allowed humans to inhabit environments that were unpredictable and often hostile. Survival did not require long planning horizons or stable conditions. It required only that reproduction continued intermittently. This lowered the biological cost of expansion. Humans could spread into new regions quickly, even if mortality was high, because losses did not erase continuity. The species advanced through trial, error, and frequent failure at the individual level. This pattern explains why early human history is marked by repeated disappearances of groups without the disappearance of the species itself. Entire communities could vanish, leaving little trace, while the lineage continued elsewhere. The human species did not rely on preserving specific populations. It relied on redundancy. Many groups existed at once, each capable of carrying the line forward. If one failed, others persisted. This distributed strategy reduced the risk of total extinction. It also reduced the evolutionary incentive to protect late life. Investing heavily in long-lived individuals would not have increased resilience. It would have concentrated survival in fewer bodies, making the species more vulnerable to sudden loss. Instead, evolution favored a system with many brief carriers rather than a few durable ones. This choice shaped human demography across deep time. Populations were often young, dynamic, and constantly renewing. Age structures were weighted toward children and young adults, with few elders. This was not a cultural preference. It was a biological outcome of early reproduction combined with high mortality. The species persisted because new lives continuously entered the system. Aging bodies exited quietly. From the perspective of continuation, this exchange was balanced. The species did not accumulate age, it replaced it. This dynamic also influenced how humans perceived time. With few long-lived individuals, historical memory was short. Experience rarely accumulated across many decades. Each generation rebuilt its understanding of the world from fragments. Yet the species endured nonetheless. Continuity did not depend on wisdom being preserved. It depended on life being restarted. This further emphasizes why longevity was unnecessary for long-term survival. The human species existed for so long because it did not bind its future to the fate of its oldest members. It allowed individuals to be lost without threatening the whole. This capacity to absorb loss without interruption is a central reason for human persistence. Evolution did not aim to protect lives equally. It aimed to keep the pattern going. By requiring so little from each individual life, the human species ensured that failure at the personal level would not become failure at the species level. Time moved forward through replacement, not endurance. The line held because it was flexible, distributed, and tolerant of disappearance. This final aspect completes the logic of early survival. Humans did not last because they resisted death. They lasted because death, after reproduction, did not matter to continuation. The species existed for so long because it was built to move on, again and again, without waiting for anyone to remain. The long survival of the human species depended not only on reproducing early, but on doing so repeatedly and in large enough numbers to offset constant loss. Replacement was not an occasional event. It was the core mechanism of endurance. Every generation of humans entered a world where disappearance was common. Injury, disease, predation, and environmental change removed individuals continuously. Survival at the species level required a steady arrival of new members to take the place of those who vanished. This created a rhythm of rapid turnover that defined human existence for most of its history. Populations remained viable not because individuals stayed, but because others arrived in time. This process did not require precision. It required volume and timing. Enough births, occurring early enough, ensured continuity. The species did not aim for balance at the individual level. It aimed for momentum. As long as replacement outpaced loss, the line advanced. This logic shaped reproductive patterns across human history. Birth rates were high, childhood mortality was severe, and adulthood was often brief. These conditions were not signs of failure. They were the environment within which the species learned to persist. High turnover created resilience. When losses occurred, they were absorbed by the next wave. The population flexed rather than shattered. This strategy contrasts sharply with species that rely on long-lived individuals to maintain stability. In those systems, losing a few key members can threaten survival. Humans avoided this vulnerability by spreading survival across many short lives. No single body was essential. The species did not depend on particular individuals. It depended on continuity emerging from repetition. This approach allowed humans to adapt behaviorally without waiting for biological change. Cultural practices could shift within a generation, even as bodies remained largely the same. Replacement accelerated learning at the species level, even if individual lives were short. New generations could adopt different strategies in response to changing conditions. If a way of living failed, it did not persist long enough to trap the species. It disappeared with those who practiced it. This flexibility was a hidden advantage of short lives and rapid replacement. The species remained responsive rather than rigid. This dynamic also explains why early human populations were often small and scattered. Survival did not require large, stable groups. It required a network of groups capable of restarting the process elsewhere if one failed. Replacement occurred not just within populations, but between them. When one group vanished, others expanded or moved. The species flowed across landscapes through repeated beginnings. Over time, this created a broad and resilient presence. The human species did not survive by defending permanence. It survived by allowing impermanence to occur without interruption. Replacement was the quiet engine of this success. It ensured that time kept moving forward even when lives ended abruptly. This engine did not eliminate suffering or loss. It rendered them survivable at the scale that mattered. The species endured because it treated individual disappearance as expected, not catastrophic. Replacement was always already underway. Each birth was not just a new life, but a continuation of a pattern that did not rely on any single outcome. Through this constant renewal, humans maintained their place on Earth for hundreds of thousands of years. The long existence of the species is inseparable from this rhythm. Without replacement, endurance would have failed. With it, survival became possible even under relentless pressure. The human species lasted because it kept arriving, again and again, faster than it was erased. The effectiveness of replacement depended not only on how often new individuals were born, but on how quickly generations turned over. In early human populations, the distance between generations was short. Children were born while parents were still young, and grandparents were uncommon. This compressed generational spacing meant that evolutionary time moved quickly, even if calendar time did not. Small changes could spread through populations faster because new generations arrived sooner. The species did not wait for bodies to endure. It advanced by cycling through them. This rapid turnover created an unexpected advantage. It allowed humans to respond to environmental pressure without requiring major biological redesign. When conditions changed, behaviors changed first. Those behaviors were then carried forward by the next generation. If they failed, they disappeared quickly. If they worked, they spread. Replacement acted as a filter, continuously testing ways of living. This process was not deliberate. It emerged naturally from short lives and early reproduction, yet over long periods, it produced remarkable adaptability. The species remained flexible because it never became biologically settled. No single form of life persisted long enough to harden into a trap. Each generation began with a clean slate shaped by inherited tendencies and immediate conditions. This flexibility mattered greatly in unstable environments. Climate shifted repeatedly during the long history of Homo sapiens. Landscapes changed, resources moved, and threats appeared and vanished. A species dependent on long-lived individuals would have carried outdated strategies forward for decades. Humans did not. Their strategies expired with their bodies. This allowed the species to stay aligned with present conditions rather than past successes. Replacement also distributed risk. Because generations overlapped only briefly, failure in one did not cascade far into the future. A disastrous period might remove many individuals, but it rarely removed the pattern itself. New births resumed as soon as conditions allowed. The species rebounded not by preserving experience, but by restarting life. This restart capacity explains why human history contains so many gaps. Cultures vanished, technologies were lost, and populations disappeared, yet the species remained. Replacement made forgetting survivable. It ensured that loss did not accumulate beyond recovery. This same process also limited how much selection invested in long-term biological stability. There was little benefit in refining bodies meant to be temporary. Evolution favored systems that worked reliably for a short span rather than perfectly for a long one. Human physiology reflects this trade-off. It performs well early, then gradually loses precision. The species accepted this because replacement filled the gap. From a distance, this looks inefficient. From deep time, it is effective. The human species endured because it never relied on continuity within bodies. It relied on continuity between them. Each life served as a brief link in a long chain. The strength of the chain did not come from any single link, but from their number and sequence. Replacement ensured that the chain kept forming even as links broke. This dynamic helps explain why human survival was not fragile despite constant loss. The system was designed, through selection, to absorb breakage. As long as new links appeared in time, the chain held. Over hundreds of thousands of years, this simple mechanism proved sufficient. The species did not need to resist change. It needed to keep moving. Replacement provided that motion. Through rapid turnover and brief overlap, humans advanced across time without requiring long-lived bodies or stable lives. The human species existed for so long because it was never still. Replacement did more than maintain numbers. It reshaped how survival itself functioned. Because individuals were expected to be temporary, the human species evolved without relying on stability at the personal level. Survival was not concentrated in elders, leaders, or particularly successful individuals. It was spread thinly across many lives. This distribution reduced dependency. If one individual failed, nothing essential was lost. If many failed, the pattern still continued elsewhere. The species learned, in evolutionary terms, to expect loss and move through it rather than prevent it. This expectation shaped the structure of early human groups. Cooperation mattered, but no single role was indispensable. Knowledge was useful, but not protected. Skills could vanish and return. The system tolerated gaps because replacement filled them. This tolerance explains why early human societies appear simple and repetitive across vast spans of time. Tools changed slowly. Lifestyles reappeared in similar forms. Innovation occurred, but it was not preserved reliably. From a modern perspective, this seems like stagnation. From an evolutionary perspective, it was stability of a different kind. The species did not advance by accumulating complexity. It survived by remaining restartable. Each generation rebuilt a functional version of human life from basic components. Replacement made this possible. It prevented errors from becoming permanent and successes from becoming rigid. The species stayed adaptable by never locking itself into a single solution. This also influenced how human populations expanded. Movement into new territories often involved loss. Groups entered unfamiliar environments and failed. Others followed and succeeded. Replacement allowed this process to repeat without threatening the species as a whole. Expansion did not require careful planning. It required persistence through repeated attempts. Each attempt was carried by new lives, not preserved ones. Over time, this created a wide geographic spread built from countless small trials. The species did not advance smoothly. It advanced unevenly, through disappearance and return. Replacement turned uncertainty into a manageable condition. It allowed humans to occupy a wide range of environments without waiting for biological specialization. When conditions changed, bodies were replaced faster than they could become obsolete. This constant renewal also limited how much selection invested in protecting later life. There was no need to sustain individuals once their role in replacement was complete. The system already had new carriers in place. This explains why many human vulnerabilities appear predictable and widespread. They are not failures of design. They are signs of a design that did not require permanence. The human species existed for so long because it accepted impermanence at every level except one. The line itself had to continue. Everything else could be lost. This single requirement shaped survival more powerfully than strength, intelligence, or longevity. Replacement ensured that time kept moving forward even when nothing else stayed. The species endured because it never depended on preservation. It depended on renewal. Each life arrived knowing nothing of the last, carrying the pattern forward briefly before disappearing. This cycle repeated so reliably that extinction was avoided despite constant pressure. The long existence of humanity rests on this quiet mechanism. Replacement did not make life easier. It made survival possible. By allowing individuals to be expendable, the species protected itself. This is the final piece of the logic. Humans did not last because they resisted loss. They lasted because loss was already accounted for. Replacement was not a response to danger. It was the foundation of endurance. The human body appears complex and capable, yet its structure reveals a clear bias toward beginnings rather than endings. From early development through young adulthood, biological systems are finely tuned. Growth is rapid, coordination improves quickly, and energy is directed toward building strength, learning skills, and reproducing. This phase receives the highest investment. After it passes, the logic shifts. Repair becomes slower, balance less precise, and resilience gradually declines. This pattern is not subtle. It is written into nearly every system of the body. Bones reach peak density relatively early, muscle mass peaks before middle age, and many organs begin a slow process of reduced efficiency soon after maturity. These changes are not signs of malfunction. They reflect priorities shaped by selection. Evolution focused on getting the body ready for life, not keeping it intact at the end. The human organism is optimized for entry, not for exit. This becomes clearer when we examine maintenance mechanisms. Cellular repair, immune surveillance, and tissue renewal work remarkably well when the body is young. Over time, these systems lose precision. Errors accumulate, damage persists longer, and recovery slows. Evolution did not fully correct this because it did not need to. Once reproduction had occurred, the continued fine-tuning of maintenance offered little advantage to the species. The body was allowed to drift. This drift is what we now call aging. It is not a programmed decline but an unprotected one. The human body was never finished in the sense modern humans expect. It was completed only up to the point required for continuation. Everything beyond that point was left vulnerable. This design also explains why many late-life conditions appear predictable rather than random. Degeneration follows similar patterns across populations because the same systems lose protection at similar times. The body was not designed to collapse suddenly. It was designed to be maintained just long enough. The gradual nature of decline reflects diminishing investment rather than catastrophic failure. From an evolutionary perspective, this was efficient. Energy devoted to perfect long-term maintenance would have reduced energy available for growth and reproduction. In uncertain environments, such trade-offs were costly. Early humans benefited more from strong beginnings than from durable endings. This logic also shaped how pain, fatigue, and physical limits are experienced later in life. These signals emerge as maintenance weakens. They were not selected against, because they appeared after the critical window had passed. The species continued regardless. Understanding this shifts how we interpret the human body. It is not a flawed machine that breaks down too soon. It is a system that was never asked to last indefinitely. Its apparent fragility in later life reflects an absence of evolutionary pressure, not a failure of design. The long existence of the human species did not depend on bodies that aged well. It depended on bodies that started well. The design favored reliable beginnings repeated many times, rather than extended endings preserved few times. This explains why humans could exist for so long without evolving robust longevity. The body did exactly what was required of it, no more and no less. It brought life into the world, carried it briefly, and then gave way to the next arrival. The species endured because the design worked where it mattered most. The human body was built to begin again, not to remain. The bias toward beginnings can also be seen in how unevenly resources are allocated within the body across time. During early life, energy is directed outward. Growth demands calories, nutrients, and constant repair. Bones lengthen, organs expand, neural connections multiply, and immune defenses are trained through repeated exposure. The body behaves as if it expects high returns on this investment because at that stage, it does. Survival through childhood and early adulthood directly affects whether reproduction occurs. After that point, the internal economy changes. Energy is conserved rather than expanded. Systems that once renewed aggressively begin to operate in maintenance mode and eventually in compromise. This shift is gradual, almost quiet. There is no clear moment when the body stops being supported. Instead, support slowly thins. Repair still happens, but less completely. Damage is still addressed, but less urgently. Over time, this imbalance becomes visible as wear. From an evolutionary standpoint, this reallocation makes sense. Energy is finite. In early human environments, calories were uncertain and often scarce. Investing heavily in long-term upkeep would have reduced the chance of surviving the early, dangerous years. Selection favored bodies that could grow, act, and reproduce efficiently rather than ones that aged gracefully. The result is a body that feels generous at first and increasingly strict later on. This design also explains why many age-related declines affect systems that are costly to maintain. Muscle tissue, bone density, and immune precision all require constant energy input. When that input decreases, these systems are among the first to weaken. The body prioritizes immediate survival over long-term stability. This is not neglect in a moral sense. It is a strategic withdrawal shaped by deep time. The species did not require individuals to remain robust indefinitely. It required them to perform intensely for a limited period. After that, further investment offered little return. This helps clarify why longevity did not emerge naturally despite the long existence of the species. There was no sustained pressure pushing bodies to last longer. The environment removed most individuals before late-life traits could influence reproduction. Even when some lived longer, their survival did not significantly affect the continuation of the line. As a result, traits that would improve late-life health remained weakly selected or not selected at all. The body reflects this history. It excels when young and slowly relinquishes capacity afterward. Modern humans often interpret this as failure because contemporary life extends far beyond the conditions that shape the body. But from an evolutionary view, the design remains consistent. It did exactly what it needed to do for most of human history. The species endured because bodies reliably crossed a narrow passage, not because they endured indefinitely. Understanding this helps explain the tension many feel between long lives and aging bodies. The mismatch is not accidental. It is the result of a design optimized for repetition, not preservation. The human species existed for so long because its bodies were efficient where it mattered most. They began well, acted decisively, reproduced, and then gradually released their hold. Longevity was not the goal. Continuation was. The body was shaped accordingly. Investing heavily in the beginning and accepting decline as an acceptable outcome once its primary task was complete. The final consequence of a body optimized for beginnings is that decline was never treated as a problem that needed solving. In early human history, aging unfolded in the background of constant external risk. Injury, infection, starvation, and environmental exposure shaped survival far more strongly than slow internal deterioration. As a result, selection pressure rarely reached the later stages of life. Traits that would improve durability at older ages remained invisible to evolution because few individuals lived long enough for those traits to influence reproduction. The body was therefore left without strong defenses against gradual breakdown. This absence of protection is not accidental. It reflects an environment where late life was statistically rare and evolutionarily irrelevant. The human body was shaped in a world where most lives ended before prolonged decline could matter. This context explains why many mechanisms that could, in theory, support long-term stability are incomplete. Cellular systems repair damage, but not perfectly. Proteins are replaced, but errors accumulate. DNA is maintained, but mutations slip through. These imperfections are tolerated because they appear slowly and mostly after reproduction. Evolution did not remove them because there was no consistent advantage in doing so. The species continued regardless. This logic also shaped how pain, fatigue, and limitation are experienced with age. These sensations act as signals of reduced capacity rather than problems to be eliminated. They reflect a body transitioning out of its primary evolutionary role. In early environments, this transition carried little consequence for survival at the species level. Others were already in place to carry the line forward. The system did not require elders to function. It required turnover. As a result, decline became an accepted feature of the human condition rather than a flaw to be corrected. This acceptance allowed the species to persist without investing in costly biological safeguards. Resources were directed toward making sure new lives could begin successfully, not toward prolonging old ones. The design favored reliability over completeness. It worked consistently enough for long enough to keep the species present. When viewed this way, the long existence of the human species is no longer surprising. It did not depend on bodies that resisted time. It depended on bodies that fulfilled a narrow role and then stepped aside. Aging was not a failure of design. It was a tolerated outcome of a design focused elsewhere. The species endured because it did not wait for bodies to last. It expected them to fade. This expectation shaped everything from physiology to population structure. Humans existed for so long because their bodies were never meant to carry the future alone. The future arrived through replacement, not preservation. Each life completed its function and yielded space to the next. This cycle required no perfection, only consistency. Over hundreds of thousands of years, that consistency proved enough. The human body, with all its limits, fulfilled the role it was shaped for. It began life efficiently, supported reproduction, and then gradually relinquished control. The species endured not by fixing decline, but by designing around it. That is the quiet reason humans have existed on Earth for so long. Across most of human history, the forces that ended lives arrived long before aging could unfold fully. Survival was shaped by the outside world more than by slow internal decline. Food shortages, infectious disease, injury, and exposure to harsh climates imposed limits that few individuals could escape. In such conditions, the question of how the body aged mattered far less than whether it survived the next season. Death was usually sudden or acute, not gradual. This reality defined the evolutionary environment in which the human species persisted. When external threats dominate, selection pressure focuses on immediate survival and early reproduction rather than long-term maintenance. Bodies were shaped to respond quickly to danger, recover from short-term stress, and reproduce as soon as conditions allowed. Long-term durability offered little advantage when few individuals reached late life. As a result, aging remained largely invisible to selection. The environment removed individuals before internal breakdown became relevant. This explains why early human populations could exist for so long without evolving strong protections against aging. The problem rarely appeared in a form that mattered to continuation. Environmental risk also varied unpredictably. Periods of abundance were followed by famine. Stable climates shifted abruptly. New pathogens emerged without warning. In such contexts, investing heavily in long-lived bodies would have been inefficient. Those bodies could still be lost suddenly. Evolution favored flexibility over endurance. A body that performed well under immediate stress had more value than one built to last under ideal conditions that rarely existed. This trade-off shaped human physiology in subtle ways. Stress responses are powerful but costly. Immune systems react strongly but sometimes imprecisely. Healing occurs quickly when young, but leaves lasting damage. These traits reflect adaptation to acute challenges rather than chronic decline. The environment demanded speed, not longevity. Another consequence of harsh conditions was that population turnover remained high. Losses were constant, but births continued. The species endured because external forces, though lethal, were uneven. Some survived, others did not, and the line continued through those who remained. This unevenness created space for survival without requiring bodies to be robust over many decades. Aging, when it occurred, unfolded in the shadow of larger dangers. It was not the primary cause of death. This context helps explain why many age-related changes appear gradual and unprotected. There was no urgent reason to prevent them. From the perspective of the species, the environment had already done its work. Individuals who reached later life did so by chance rather than by design. Their survival did not shape the future of the line. Over time, as external threats dominated mortality, the species adapted to live within that reality. Social behaviors emerged that mitigated immediate risks rather than long-term decline. Cooperation improved hunting success. Shared food, reduced starvation, and group living offered protection. These strategies extended survival just enough to allow reproduction, not enough to eliminate aging. The species did not need to conquer time, it needed to navigate danger. This pattern remained stable for most of human existence. Only very recently have external threats diminished enough for aging to become a primary concern. For hundreds of thousands of years, death usually arrived from outside before it arrived from within. The human species existed for so long because it adapted to that world. Bodies were shaped to meet immediate challenges repeatedly rather than to endure indefinitely. Aging was allowed to proceed quietly because it rarely determined survival. The environment set the limits, and those limits were reached early. Understanding this helps explain why longevity feels mismatched to modern life. The body carries the imprint of a past where growing old was uncommon and unnecessary. The species endured not by resisting the world, but by moving through it quickly enough to leave descendants behind. In environments where danger was constant, survival depended on responding to immediate threats rather than preparing for distant decline. For early humans, daily life involved physical risk that left little room for long-term planning. Hunting large animals carried the chance of injury. Gathering food exposed bodies to toxins, parasites, and accidents. Living without shelter or medical care meant that minor wounds could become fatal. Under these conditions, the body's priorities were shaped by urgency. Systems that supported quick reaction, short bursts of strength, and rapid recovery were favored, even if they produced lasting damage. Long-term wear was an acceptable cost when short-term survival was uncertain. This environment also shaped how disease influenced human survival. Infections were common and often lethal, especially before immune systems could adapt. Many illnesses struck quickly, ending lives long before aging-related decline became relevant. Selection therefore favored immune responses that acted fast, not ones that preserved long-term balance. Strong inflammatory reactions could save a life in the moment, but increase damage later. From the perspective of continuation, this trade-off was worthwhile. The species benefited more from surviving immediate infection than from protecting tissues decades later. Environmental instability reinforced this logic. Climate fluctuations altered food availability and living conditions repeatedly. Periods of cold or drought placed intense pressure on populations. During such times, survival hinged on mobility, cooperation, and rapid adaptation rather than physical endurance. Bodies that could act decisively under stress were more likely to leave descendants than bodies optimized for longevity under stable conditions. This favored traits that performed well in crisis but aged poorly afterward. Aging, again, remained outside the focus of selection. External forces determined who lived and who died. The unpredictability of these forces also limited how much evolution could invest in preserving later life. A body built to last many decades could still be lost suddenly to famine or violence. In such a world, durability offered no guarantee. Flexibility and speed offered better odds. The human species adapted accordingly. Survival strategies emphasized group behavior, shared risk, and rapid response rather than individual longevity. This helped populations persist even when mortality was high. Aging unfolded quietly in the background, rarely becoming the decisive factor in survival. This context explains why age-related decline appears consistent across human populations despite vastly different cultures. The underlying pressures were similar. External threats dominated mortality everywhere humans lived. As a result, There was little variation in how bodies handled later life. Selection never strongly favored one aging pattern over another, because aging rarely influenced reproductive success. Individuals who reached advanced age were exceptions rather than drivers of evolution. Their bodies carried no special advantage for the species. Over time, this produced a species well adapted to danger but poorly adapted to extended safety. When modern conditions reduced external threats, aging emerged as a primary challenge for the first time. The body, shaped by a long history of acute risk, now faces a world where slow decline matters more than sudden loss. This mismatch reveals how deeply environment shaped human survival. The species existed for so long because it mastered life under threat. Aging was tolerated because it was overshadowed by more immediate dangers. The body learned to survive the present, not the future. This strategy carried humanity through deep time, even though it left individuals vulnerable once danger receded. Within this world of constant danger, survival patterns became shaped by what killed fastest rather than what wore down slowly. Mortality followed sharp curves rather than gentle slopes. Lives ended abruptly through injury, infection, or scarcity, often without warning. Under such conditions, slow internal decline rarely determined outcomes. Aging unfolded, but it unfolded behind louder forces. Because death usually arrived from outside, selection had little reason to notice what happened inside the body over long spans of time. This blindness had consequences. Traits that might have improved stability later in life were neither favored nor refined. They remained weak, inconsistent, or absent altogether. The environment set the terms, and those terms were immediate. This dynamic also influenced how human populations experienced time. With few individuals reaching advanced age, societies rarely organized around long-term accumulation of experience. Skills were practical and quickly learned. Knowledge that could not be transmitted easily disappeared. Survival depended more on adaptability in the present than on preserving the past. This reinforced a short horizon of concern. Bodies and behaviors were shaped for what mattered now, not for what might matter decades later. Aging, again, remained peripheral. When it did appear, it was treated as an expected fading rather than a crisis to be prevented. This acceptance further reduced any pressure to counteract decline. The species did not invest in resisting what was rarely decisive. Environmental dominance over mortality also explains why aging-related traits appear remarkably similar across human populations. Despite differences in climate, culture, and geography, the basic pattern of decline follows familiar paths. Muscles weaken, bones thin, immunity falters. These outcomes are not culturally produced. They reflect a shared evolutionary history in which late-life performance rarely influenced survival. Selection never strongly differentiated aging strategies because the environment overshadowed them everywhere humans lived. This produced a species well adapted to danger and poorly adapted to prolonged safety. When danger receded, the limits of this adaptation became visible. Only in recent history did external threats diminish enough for aging to emerge as a primary cause of death. This shift exposed a body shaped for a different world. The long existence of the human species was achieved under conditions where time itself was unstable. Seasons failed, climates shifted, and threats changed quickly. In such a world, longevity offered no reliable advantage. Survival depended on responsiveness rather than endurance. Bodies that could act, recover briefly, and reproduce were sufficient. Bodies that age well were unnecessary. This logic remained stable for hundreds of thousands of years. The species endured because it matched the rhythm of its environment. Aging was allowed because it did not interrupt continuation. Only when the environment changed did aging become visible as a problem. By then, the species had already secured its long presence on Earth. Understanding this clarifies why the human body feels misaligned with modern expectations. It carries the imprint of a past where growing old was uncommon and irrelevant. The species existed for so long not because it solved aging, but because it lived in a world where aging rarely decided survival. External forces shaped life more strongly than internal decay. When those forces dominated, the species did not need to change. It only needed to persist long enough to reproduce again. That simple requirement, met repeatedly under harsh conditions, carried humanity through deep time. Aging remained an unaddressed detail because the world itself ended lives before time could. This final perspective completes the picture of why environment, rather than biology alone, explains the long existence of the human species. Across the long span of human existence, survival gradually shifted away from physical strength alone and towards something less visible but more durable. Cognitive flexibility, learning, and shared understanding began to compensate for bodily limits. While the human body remained vulnerable and short-lived, the human mind introduced a new layer of endurance. Knowledge could outlast individuals. Behaviors could be repeated without being genetically encoded. This change altered how the species survived without changing how long individuals lived. Early humans did not evolve stronger claws, thicker skin, or longer lifespans. Instead, they learned. They observed patterns in animals, seasons, and landscapes. They remembered where food appeared and where danger hid. More importantly, they shared this information. Survival no longer depended solely on what one body could do. It depended on what many minds could accumulate and pass on. This shift reduced the evolutionary need for durable bodies. When skills and strategies could be learned rather than inherited biologically, bodies no longer needed to adapt slowly across generations. Behavior could change within a single lifetime. A group that learned to hunt differently, use tools more effectively, or cooperate more closely could survive even if its members remained physically fragile. The species gained resilience without altering its biology. This was a profound advantage. Cultural learning allowed humans to respond to new environments faster than genetic evolution ever could. When climates changed or resources shifted, behaviors adjusted first. Bodies followed only if necessary. In many cases, they did not need to. The same vulnerable human body could survive in deserts, forests, tundra, and coastlines simply by learning new ways of living. This reduced pressure to evolve specialized physical traits or longer lifespans. The mind carried adaptation forward while the body remained largely unchanged. Memory also played a critical role. Individual memory was limited by lifespan, but shared memory extended beyond it. Stories, imitation, and teaching allowed information to survive the death of those who discovered it. Even when details were lost, enough structure remained to rebuild. This imperfect transmission was still sufficient. The species did not require perfect preservation of knowledge. It required continuity. Each generation learned enough from the previous one to survive, even if much was forgotten. This parallels the biological strategy already in place. Just as bodies were replaceable, so was knowledge. Loss did not stop survival, it only slowed it briefly. Over time, this created a system where survival relied less on biological durability and more on collective learning. The body could age and fail because the mind had already extended survival beyond it. Skills lived on in others. This further reduced evolutionary pressure to invest in long-term bodily maintenance. Why preserve a body for decades if its most valuable contributions could be transferred quickly? The species benefited more from fast learning and cooperation than from long-lived individuals. This explains why humans could exist for so long without evolving bodies suited for longevity. Intelligence and culture compensated for physical limits without removing them. The species survived by becoming mentally flexible rather than biologically durable. This flexibility also allowed humans to absorb loss. When individuals died, knowledge did not vanish entirely. Others carried fragments forward. Survival continued through partial memory and repeated learning. Over hundreds of thousands of years, this system proved reliable enough. The human species endured not because bodies lasted, but because understanding moved between them. Culture became a form of survival independent of lifespan. This marked a turning point. From that moment onward, human endurance relied less on the body and more on the space between bodies. That space was filled with shared memory, imitation, and learning. Through it, the species extended itself across time without extending individual lives. Through shared learning, survival knowledge became detached from any single lifespan. What mattered was not how long one person remembered, but whether enough people remembered enough at the right time. This collective memory did not need to be accurate or permanent. It needed only to function. Early human groups relied on imitation more than explanation. Young members copied behaviors that appeared to work. If those behaviors failed, they disappeared with the individuals who practiced them. If they succeeded, they spread. This created a living system of trial and correction that operated faster than biological change. The species adapted by forgetting and relearning rather than by refining bodies. Such a system reduced the cost of error. Mistakes were not carried forward for centuries. They were erased within a generation. This allowed humans to explore risky strategies without endangering long-term survival. A hunting method that failed could be abandoned quickly. A tool that broke could be replaced with another idea. Bodies remained fragile, but behavior remained flexible. This flexibility was crucial in environments that shifted unpredictably. Climate, prey availability, and competition changed faster than genes could respond. Cultural transmission filled that gap. It allowed the species to adjust without waiting for slower biological solutions. Over time, this reliance on shared learning altered the balance of survival. Biological durability became less important because knowledge could compensate for physical weakness. Fire reduced vulnerability to cold, tools reduced the need for strength, cooperation reduced individual risk. Each of these innovations extended survival indirectly without extending lifespan itself. The body remained short-lived, but its effective reach increased. This further weakened any evolutionary incentive to protect the body beyond early adulthood. If survival could be maintained through shared strategies, then preserving aging bodies offered diminishing returns. The species benefited more from rapid knowledge transfer than from long-lived carriers. Even elders, when present, were valuable primarily as sources of information rather than as reproductive contributors. Their role, when it existed, was cultural, not biological. This distinction matters. Culture could persist without elders, but elders could not persist without culture. The system did not depend on any individual remaining alive. It depended on enough learning occurring before death. This created a quiet redundancy. Knowledge did not need a single guardian. It could be scattered across many minds. When one was lost, others retained fragments. Together, those fragments were enough. Over long periods, this distributed memory supported continuity despite constant loss. The species did not need perfect transmission. It needed resilience to forgetting. Cultural learning provided that resilience. It allowed humans to exist for so long without evolving long-lived bodies or robust late-life maintenance. The mind extended survival beyond the body's limits without altering those limits. In doing so, it reinforced the pattern already established by reproduction and replacement. Individuals remained temporary, but the system endured. Survival became something that happened between people rather than within them. This shift reduced pressure on biology and increased reliance on connection. Over hundreds of thousands of years, this arrangement proved stable enough to prevent extinction. The human species endured because it learned how to survive collectively, not because it solved the problem of individual fragility. Knowledge moved forward even as bodies faded. This balance allowed the species to persist through environments that would have destroyed a lineage dependent on long-lived individuals. Culture did not make humans immortal, it made them repeatable. That repeatability, combined with shared learning, carried the species forward across deep time without requiring bodies to last longer than they ever had. Over time, reliance on shared understanding reshaped what survival meant for the human species. Physical limits no longer defined the boundary of endurance. Instead, survival became embedded in relationships, routines, and repeated patterns of behavior. A single human body remained vulnerable, but a group that learned together could persist even when many members were lost. This collective structure functioned as a buffer against extinction. When one person died, the knowledge they carried did not vanish entirely. Others retained parts of it, enough to rebuild what was needed. Survival therefore became distributed across minds, rather than stored within bodies. This distribution reduced the evolutionary importance of preserving any individual beyond their reproductive years. Once learning known to the group had been absorbed, the body that first carried it was no longer essential. The species moved forward through shared competence rather than personal endurance. This mechanism explains why human evolution invested so heavily in social cognition. Abilities such as imitation, communication, and cooperation were not simply cultural traits. They were survival tools that allowed the species to persist without altering its biological lifespan. Humans did not need stronger bodies if they could rely on one another. They did not need longer lives if what they learned could be transferred quickly. This made survival scalable. Groups could grow, split, disappear, and reform without threatening the continuity of the species. Each group carried a partial version of what it meant to be human. Together, these fragments formed a resilient whole. Loss became survivable because no single loss erased everything. This also changed how risk was managed. Dangerous environments could be entered because failure did not end the line. If one attempt collapsed, others succeeded elsewhere. Knowledge accumulated slowly across populations, not within individuals. The species advanced unevenly, but it advanced nonetheless. This uneven progress required no long-lived witnesses. It required only repetition. Each generation relearned enough to function. Over long periods, this repeated learning created stability without permanence. From an evolutionary perspective, this was sufficient. The human species existed for so long because it learned to externalize survival beyond the body. Tools, shelters, and social bonds extended life just enough to allow reproduction and learning. Beyond that, decline was acceptable. Aging did not need to be solved because its effects were softened by collective support. Older individuals, when present, benefited from shared resources. Younger individuals benefited from inherited practices. The system worked even when bodies failed. This further reduced selection pressure on late-life maintenance. Why preserve a body when its contributions had already been absorbed by others? The species thrived by letting go. Over hundreds of thousands of years, this pattern repeated reliably. Human endurance rested on cooperation rather than durability, on learning rather than longevity. Culture acted as a bridge across time, allowing the species to remain present without extending individual lives. This explains why humans could exist for so long despite fragile bodies and short lifespans. Survival was no longer confined to biology alone. It was woven into the space between people. That space carried memory, skill, and continuity forward even as bodies disappeared. The human species endured because it became something more than the sum of its lives. It became a repeating structure of shared understanding that did not depend on anyone staying. In this way, culture completed what biology did not need to finish. It allowed the species to last without asking individuals to do the same. Across different environments, human survival depended less on perfect adaptation to one place and more on the ability to function reasonably well in many. Unlike species that evolved narrow specializations, humans remained broadly flexible. Bodies were not optimized for speed, strength, camouflage, or endurance in any single environment. Instead, they were capable of tolerating a wide range of conditions without excelling in any one of them. This generalist strategy played a crucial role in long-term survival. By avoiding deep specialization, the human species reduced its vulnerability to environmental change. When climates shifted or resources disappeared, specialized species often struggled. Humans, by contrast, could adjust behavior without waiting for biology to change. This adaptability allowed the species to move, settle, abandon, and resettle repeatedly without losing continuity. Flexibility became a form of protection. Biological specialization locks a species into a narrow ecological niche. Humans avoided this lock by remaining incomplete. Hands were versatile rather than optimized for a single task. Teeth were general purpose rather than specialized for one diet. Metabolism could tolerate varied food sources. None of these traits made humans dominant in any one setting, but together they made humans difficult to eliminate. When one strategy failed, another could be tried. This openness reduced extinction risk across long periods of instability. Environmental variability was a constant feature of human history. Ice ages advanced and retreated. Forests turned into grasslands. Coastlines shifted. A species finely tuned to one condition would have struggled to persist. Humans survived by remaining adaptable rather than efficient. Cultural learning amplified this biological flexibility. Tools and behaviors filled the gaps left by non-specialized bodies. Clothing compensated for lack of fur. Fire compensated for limited digestive specialization. Shelters compensated for exposure. Each of these solutions allowed the same basic body to function in radically different environments. This reduced pressure to evolve new physical traits for each setting. Instead of becoming many specialized species, humans remained one flexible species spread across many niches. This unity mattered. Maintaining a single adaptable form prevented fragmentation. The species did not divide into narrowly adapted branches that could be lost independently. It stayed cohesive enough to persist even as groups separated geographically. When one group failed, others survived elsewhere under different conditions. This redundancy supported long-term existence. The generalist strategy also shaped lifespan indirectly. Specialization often requires long development and long maintenance. Humans avoided this cost. By relying on behavior rather than biology, they could function effectively without extended physical refinement. Bodies reached functional maturity quickly and did not require long-term upkeep to remain useful. Aging did not threaten this system because adaptability was carried by behavior rather than physical perfection. Decline could occur without collapsing survival strategies. Younger members could learn and replace older ones without needing bodies optimized for decades of performance. This further reduced evolutionary pressure to extend lifespan. Flexibility at the species level compensated for fragility at the individual level. Over time, this approach proved robust. Humans occupied deserts, mountains, forests, and coastlines, using the same basic biological template. Few species have managed this without extreme specialization or long lifespans. Humans achieved it through incompleteness. By remaining adaptable rather than perfected, the species maintained relevance across changing conditions. This adaptability did not eliminate risk. Many groups failed. Many strategies ended. But failure did not accumulate into extinction. The species endured because it could keep trying. Generalism allowed repeated attempts without irreversible commitment. The human species existed for so long because it never required the world to stay the same. It required only the ability to adjust. Flexibility replaced specialization as the foundation of survival. That choice shaped bodies, behavior, and the long arc of human existence. In contrast to highly specialized species, humans carried fewer biological commitments that could become liabilities. Specialization often brings efficiency, but it also narrows options. A body optimized for one food source, one climate, or one mode of movement becomes vulnerable when those conditions change. Human bodies avoided that trap. Their capabilities overlapped rather than focused. This overlap created redundancy. When one function was limited, another could compensate through behavior. Such redundancy reduced the cost of failure. Losing access to a particular resource did not require immediate biological change. It required adjustment. This adjustment could occur within a lifetime. Tools could be altered. Diets could shift. Movement patterns could change. None of this demanded new anatomy. As a result, the species remained viable across transitions that eliminated more specialized competitors. This mattered deeply over long periods marked by repeated instability. Environmental change was not a rare event in human history. It was the norm. Under such conditions, a generalist design offered durability at the species level, even if individuals remained fragile. Flexibility also influenced how populations spread. Humans did not need to wait for favorable conditions to be perfected. They could enter marginal environments and survive at lower efficiency while experimenting with solutions. Some experiments failed, others succeeded. Replacement and learning absorbed the cost. Over time, this allowed gradual occupation of diverse regions without committing the species to any single ecological identity. The species stayed light, able to move on when conditions worsened. This lightness reduced extinction risk. Cultural practices amplified the benefits of generalism. Instead of evolving specialized digestive systems, humans learned to process foods. Instead of evolving insulation, they learned to make clothing. Each cultural layer extended adaptability without narrowing biological options. This separation between body and behavior allowed the same human form to remain useful under vastly different circumstances. Longevity was not required for this system to work. Knowledge transferred quickly. Young individuals learned strategies early and replaced older ones without loss of capacity. The species advanced through substitution rather than preservation. Generalism also shaped social organization. Groups remained small and mobile, able to reorganize when resources shifted. Social roles were flexible rather than fixed. Individuals could adapt to different tasks as needed. This fluidity prevented rigid dependence on specific members. When losses occurred, groups adjusted rather than collapsed. Such resilience did not require bodies to last long. It required systems to remain adaptable. Aging, therefore, posed little threat to this arrangement. Decline in individual capacity could be offset by others stepping into roles. The species did not rely on prolonged individual performance. It relied on collective versatility. This further reduced evolutionary pressure to extend lifespan. Specialization often benefits from long-lived experts. Humans avoided that dependency. Expertise could be rebuilt. Skills could be relearned. The cost of rebuilding was lower than the cost of maintaining bodies indefinitely. Over deep time, this balance favored survival without longevity. The human species existed for so long because it avoided being trapped by its own success. Each solution remained provisional. Nothing was perfected enough to become indispensable. This allowed continual adjustment without catastrophic failure. Flexibility remained central, even as environments changed repeatedly. The species endured by staying unfinished. Generalism prevented commitment to paths that could later close. Through this openness, humans maintained presence across shifting landscapes and climates without requiring biological durability. The body remained adaptable enough, and behavior filled the rest. This strategy, repeated across countless generations, proved sufficient. The species lasted because it did not demand stability from the world or permanence from its members. It demanded only the capacity to adapt again. Over many generations, the refusal to specialize deeply shaped not only where humans lived, but how long the species remained present. Generalism created a buffer against irreversible mistakes. When a specialized species commits to a narrow path, failure can be final. Humans avoided this outcome by keeping options open. Bodies did not lock the species into a single solution. Behavior remained adjustable, and adjustment could occur repeatedly. This reduced the stakes of any one decision. A failed strategy did not doom the species. It disappeared quietly and was replaced. This constant revisability allowed humans to persist through cycles of error without accumulating fatal consequences. Survival became a process of continual correction rather than perfect execution. Generalism also limited how much the species depended on long-term stability. Specialized organisms often require stable conditions to maintain their advantage. Humans did not. They could function imperfectly under many conditions rather than optimally under one. This imperfection was protective. It allowed the species to remain viable even when environments changed faster than adaptation could follow. Aging bodies fit into this system without disruption. Decline did not eliminate essential capacities because no single capacity was essential. When strength faded, tools compensated. When speed declined, cooperation compensated. When memory weakened, shared practices compensated. The system did not require any one body to remain capable for long. It required enough bodies to remain adaptable for a short time. This further reduced evolutionary pressure to extend lifespan. Longevity offered no decisive advantage when adaptability could be rebuilt continuously. Each generation learned anew how to function within its environment. If learning failed, the cost was limited to that generation. Others followed. This pattern explains why human evolution shows relatively little change in basic body form across vast spans of time. The body remained good enough for many uses without being perfect for any. Specialization would have demanded refinement and maintenance. Generalism allowed persistence without perfection. The species stayed present by remaining unfinished. This unfinished state was not weakness, it was resilience. By avoiding biological commitments that could become obsolete, humans kept the door open to survival under changing conditions. Cultural solutions could be added or removed without altering the underlying form. This flexibility also supported expansion without fragmentation. Humans remained one species rather than splitting into many narrowly adapted branches. Unity reduced extinction risk by spreading survival across many environments simultaneously. When one region failed, others sustained the line. The generalist body made this possible. Over deep time, this strategy proved remarkably stable. Humans endured ice ages, droughts, and ecological shifts without requiring radical biological redesign. They adjusted behavior instead. Aging continued to occur, but it did not threaten continuity. Decline affected individuals, not the pattern. The species endured because it never demanded more from bodies than they could reliably provide. Adaptability replaced durability as the foundation of survival. This final piece completes the logic of generalism. Humans existed for so long because they avoided the trap of specialization. They remained flexible enough to endure repeated change without needing to last individually. Survival was achieved not by perfect bodies or long lives, but by staying open to revision. The species persisted by being able to try again. Generalism made repetition possible. Through repetition, humanity remained. Across almost all of its existence, the human species lived within a narrow band of survival that looks very different from modern life. Average lifespans were short, mortality was high, and few individuals reached advanced age. What we now consider a long life was rare enough to have little influence on how the species evolved. This makes modern longevity an unusual event in human history, rather than its natural continuation. For hundreds of thousands of years, most humans died young, often before internal decline became a defining factor. The long existence of the species unfolded almost entirely without old age as a common experience. This context matters. Evolution shaped humans in a world where extended lifespan was not the norm and did not need to be supported. Only recently did conditions begin to change. Improvements in food stability, shelter, hygiene, and later medicine reduced external threats that once dominated mortality. As these pressures eased, more individuals survived beyond early adulthood and into later life. For the first time, aging became widespread enough to be noticed. Yet the body had not been shaped for this outcome. The biological design remained anchored in a past where such survival was uncommon. This created a gap between lifespan and biological preparation. Modern humans began living longer without corresponding evolutionary changes to support that length. Longevity emerged faster than adaptation could follow. This explains why aging feels like a problem now when it rarely did before. The species had not needed to address it. Extended life also altered the meaning of survival. In earlier periods, success was measured by continuation across generations. In modern contexts, success is often measured by years lived and quality of late life. These measures reflect new conditions rather than ancient priorities. The human body did not evolve to maximize lifespan. It evolved to pass through a critical window and move on. The appearance of long-lived populations does not signal a completed evolutionary project. It signals a recent shift in environment. This shift exposes limits that were always present but rarely reached. As more individuals survive into later decades, vulnerabilities that were once irrelevant become visible. Systems that functioned adequately for a short life struggle over a long one. Degeneration, chronic disease, and cognitive decline emerge as dominant challenges. These are not failures of evolution. They are the result of extending life beyond the conditions that shape the body. The species can now observe aging because it has outpaced the environment it was built for. This observation can feel unsettling, but it also clarifies why the human species existed for so long without addressing longevity directly. Longevity was not required for survival. Continuation was achieved without it. Only when external threats diminished did the absence of long-term maintenance become apparent. The long existence of humanity was secured under conditions where living long was unnecessary and uncommon. Modern life has altered that balance. Humans now inhabit a world that allows bodies to persist beyond their original design parameters. This persistence reveals biological limits rather than transcending them. Understanding this reframes modern aging. It is not evidence that the species failed to evolve properly. It is evidence that the species succeeded under very different conditions. The long history of human survival unfolded with short lives and constant replacement. Longevity arrived late, carried by environmental change rather than biological redesign. This late arrival explains why extended life feels mismatched with the body. The species existed for so long without old age because it did not need it. Old age emerged only when the world changed enough to allow it. That change did not rewrite human biology. It merely revealed what had always been there. This perspective situates modern longevity as an exception in deep time, not its foundation. Within this recent expansion of lifespan, a profound mismatch became visible between how long humans live and what their bodies were prepared to sustain. Survival conditions changed faster than biology could respond. Clean water, stable food supplies, reduced violence, and medical intervention removed many of the external forces that once ended lives early. As a result, individuals began reaching ages that were previously rare. Yet the body remained shaped by a much older world. Its systems were calibrated for a shorter horizon. This mismatch explains why modern longevity exposes weaknesses rather than strengths. Organs that functioned reliably for decades struggle when asked to perform for twice that length. Repair mechanisms slow, errors accumulate, and chronic conditions emerge. These outcomes are not new diseases in essence. They are extensions of processes that were once cut short by earlier death. When life is extended, decline is extended with it. The body reveals what was always unfinished. This change also altered population structure in ways evolution never encountered. For most of human history, populations were dominated by the young. Today, older adults represent a significant and growing proportion. This shift places demands on bodies and systems that were never common enough to shape selection. Late-life health now matters socially and personally, but it remains weakly grounded in evolutionary history. The species did not evolve under conditions where large numbers of individuals lived long past reproduction. As a result, traits that would support sustained function in later life were not strongly selected. They remain fragile, variable, and incomplete. The modern world asks more of the body than it was built to deliver. This does not mean the body is failing. It means the environment has changed. Longevity has increased without a corresponding increase in biological preparation. Cultural and technological solutions compensate partially. Medicine manages symptoms. Social systems redistribute care. Yet these solutions operate around a biological core that has not fundamentally changed. The same human body persists, carrying the same priorities set by deep time. This persistence highlights a key point. The long existence of the human species was never dependent on individuals living long lives. It was secured under conditions where early death was common and survival was achieved through replacement, learning, and flexibility. Modern longevity is an overlay on this foundation, not its cause. It reveals the limits of a design that worked extremely well for hundreds of thousands of years under different pressures. As individuals live longer, the costs of that design become visible. Aging, once a background process, becomes central. Yet the species continues because it never required aging to be solved. Continuation was always possible without it. This perspective reframes modern concerns about longevity. They arise not because evolution failed, but because success under one set of conditions created vulnerability under another. The human species existed for so long by optimizing for a world of risk and scarcity. The modern world reduces those risks, allowing life to stretch beyond its original frame. That stretching exposes tension, not error. Understanding this helps place modern aging in context. It is not a problem evolution forgot to fix. It is a condition evolution never needed to address. The long history of humanity unfolded without widespread old age. Only recently has old age become common enough to matter. The species did not change to accommodate it. Instead, humans adapted culturally and technologically around a body that remains rooted in its past. This gap between lifespan and design defines much of the modern human experience. It also explains why the human species could exist for so long without evolving long-lived bodies. Longevity arrived after survival had already been secured. The species endured first. Living long came later. Over the last few centuries, the extension of human life unfolded unevenly, revealing how accidental modern longevity truly is. Gains in lifespan did not arrive through gradual biological refinement. They appeared suddenly through changes outside the body. Sanitation reduced infection. Agriculture stabilized food supply. Technology softened exposure to climate. Medicine intervened when systems failed. None of these altered the underlying design of the human organism. They altered the environment in which that organism operated. As a result, lives stretched longer without becoming fundamentally different. This distinction matters. Longevity emerged as a side effect, not as an evolutionary goal. Because it was not selected for, it remains fragile. Remove the supporting conditions, and lifespan contracts again. This fragility shows how little modern longevity resembles the long-term survival strategy of the species. For most of human existence, continuation did not depend on protecting bodies indefinitely. It depended on navigating risk repeatedly. Modern longevity interrupts that pattern without replacing it biologically. The species now relies on external systems to sustain lives beyond what bodies can manage alone. This reliance highlights the difference between existence and endurance. Humans have existed for a long time because they could replace themselves under harsh conditions. Living long is a different achievement, one supported by culture rather than evolution. As longevity increased, a new kind of vulnerability appeared. Extended life magnified internal decline. Conditions that were once rare became common. Degenerative diseases, cognitive impairment, and chronic weakness moved to the center of human experience. These conditions are not signs of decline at the species level. They are expressions of a body operating beyond its original parameters. The species remains present because it never required individual bodies to remain strong indefinitely. Modern society asks for something evolution never promised. This mismatch does not threaten the existence of humanity. It challenges expectations about what long life should feel like. From a deep time perspective, modern longevity is a temporary arrangement. It depends on maintaining favorable conditions continuously. The human species has survived far longer under conditions of instability than it has under stability. This suggests that the core reason for long existence lies elsewhere. Survival was secured by flexibility, replacement, and shared learning, not by extending individual lifespan. Longevity adds complexity but does not define endurance. When viewed this way, the question of why humans have existed for so long separates from the question of why humans now live longer. The first has an evolutionary answer rooted in deep time. The second has a historical answer rooted in recent change. Confusing the two leads to misunderstanding. Humans did not last because they lived long. They lived long only after they had already lasted. This reversal clarifies the structure of human history. Existence came first. Longevity came later. The species endured through conditions that made long life unnecessary and uncommon. Only after endurance was secured did life begin to stretch. That stretching exposed limits but did not undermine survival. The long presence of humanity rests on mechanisms that operate independently of lifespan. Modern longevity is an overlay, not a foundation. It reveals the boundaries of a design shaped for a different world. Understanding this completes the picture of why the human species could exist for so long without evolving bodies built to last. Survival was achieved without longevity. Longevity arrived after survival no longer needed it. This distinction explains both the strength and the fragility of the modern human condition. As modern humans began living far longer than any previous generation, a quiet tension emerged between inherited biology and extended lifespan. Bodies shaped for brief usefulness were now expected to function for many decades. This expectation created strain rather than harmony. Systems that once needed to operate reliably for a short window were pushed far beyond their original limits. Maintenance that was sufficient for early adulthood became inadequate when stretched across long lives. This mismatch did not arise because evolution made a mistake. It arose because circumstances changed faster than biological design could follow. The human body entered an era it had never prepared for. Under these conditions, decline became more visible and more prolonged. Weaknesses that once appeared briefly before death now unfolded slowly across years. Joints degraded gradually. Metabolism drifted off balance. Cognitive clarity faded unevenly. These processes were always present, but they were rarely experienced fully. Modern longevity allows them to dominate lived experience. This shift altered how aging is perceived. What was once a quiet background process became a central feature of life. Yet the underlying biology did not change. The same priorities remained embedded in the body. Energy continued to favor immediate function over long-term repair. Selection had never refined mechanisms to support decades of late-life stability. As a result, extended life exposed unfinished systems rather than completed ones. This exposure can feel like failure, but it is better understood as revelation. The body is doing what it always did, only for longer. This mismatch also explains why aging unfolds unevenly among individuals. Some systems degrade faster than others. Some people remain functional longer, others decline earlier. Evolution never standardized late-life performance because it never needed to. Variation persisted because it carried little cost to continuation. Modern conditions amplify that variation, making aging appear unpredictable and personal. In reality, it reflects weak selection pressure in late life. No strong biological script governs what happens after the reproductive window closes. Each body follows its own path of gradual release. This variability complicates modern expectations. Medicine can delay symptoms and manage decline, but it cannot rewrite priorities set by deep time. Technology extends life without extending biological preparation. The species now relies on intervention rather than adaptation to maintain function late in life. This reliance works, but it remains external. Remove support, and the body reverts to its older pattern. This reveals an important distinction. Human existence was secured through evolutionary strategies that did not require long lives. Extended lifespan is supported through historical and technological means. Layered on top of that foundation, the foundation remains unchanged. As a result, modern humans experience a prolonged encounter with limits that were once brief. This encounter reshapes how life feels, but not how survival operates at the species level. The species continues because it never depended on individuals lasting this long. It depended on renewal, flexibility, and learning. Extended life adds complexity but does not redefine endurance. Understanding this helps place modern aging in context. It is not a problem evolution forgot to solve. It is a consequence of living beyond evolutionary necessity. Bodies are asked to persist in a state they were never refined to maintain. This request reveals boundaries rather than failures. The long existence of the human species was achieved without resolving these boundaries. Modern longevity simply brings them into view. The species remains present because its survival mechanisms operate independently of late-life performance. That separation explains why humanity could exist for so long, and why modern humans now feel the strain of lasting longer than their design anticipated. Across extended lifespans, another consequence of this mismatch becomes apparent in how responsibility for survival shifts away from biology and toward management. When bodies were short-lived, survival relied on built-in priorities that operated automatically. Growth happened early. Repair was sufficient for a limited span. Decline followed quietly. Modern longevity interrupts this simplicity. As life stretches, survival becomes something that must be actively maintained. Diets are adjusted, activity is regulated, symptoms are monitored, and interventions are applied. The body no longer carries survival on its own. It requires guidance. This shift reveals how little late-life stability was embedded in human biology. Extended life demands constant correction rather than natural balance. Systems that once ran acceptably on default settings now drift unless continually managed. This creates a new form of fragility. Survival depends not only on the body, but on sustained external support. When that support falters, decline accelerates. This dependence highlights how different modern endurance is from evolutionary endurance. The species endured for a long time without asking individuals to manage their own longevity. Modern humans must now do exactly that. This requirement also reshapes inequality in survival. Access to care, knowledge, and resources influences how long bodies can be sustained beyond their original design. Biology alone no longer determines outcome. External systems play a decisive role. From a deep time perspective, this is unprecedented. Evolution produced a body that could survive long enough without supervision. Modern life asks for supervision across decades. The strain created by this demand appears in the prevalence of chronic conditions. Diseases that emerge slowly require ongoing management rather than one-time recovery. The body was not optimized for this mode of existence. It was optimized for acute challenges and brief recovery. Prolonged maintenance exposes limits that were never selected against. This does not threaten the species, but it reshapes individual experience profoundly. Another effect of extended life is the accumulation of partial decline rather than complete failure. Systems do not collapse all at once. They degrade unevenly. Hearing weakens before vision. Mobility declines before cognition, or the reverse. This unevenness reflects the absence of a unified late-life design. Evolution never coordinated these systems for long-term harmony because there was no need. Modern longevity forces coordination where none was planned. Medicine attempts to supply it, but results remain imperfect. Each intervention addresses a local problem without redesigning the whole. This patchwork approach keeps bodies functioning longer, but it does not restore coherence. The body becomes a collection of managed systems rather than an integrated whole. This condition can feel unnatural because it is. It arises from extending life beyond evolutionary necessity. The human species can tolerate this because survival no longer depends on biological elegance. It depends on continuity and support. The long existence of humanity was never built on perfect bodies. It was built on systems that allowed replacement and learning to continue. Modern life adds a new layer of complexity without altering that foundation. Individuals may struggle with prolonged decline, but the species remains secure. This distinction is important. The discomfort of modern aging does not signal a failure of human survival strategy. It signals a shift in what survival asks of individuals. Endurance has moved from being automatic to being managed. That management reveals how provisional longevity remains. It works, as long as conditions are maintained. Remove them, and the body reverts to its older rhythm. From this view, modern longevity is fragile not because humans are weak, but because it rests on systems outside biology. The human species existed for so long because it did not require those systems. It required only that life continued through replacement and learning. Extended lifespan changes how life is experienced, not how existence is secured. The species endures because its deepest survival mechanisms operate independently of how long any one body lasts. Modern humans now live long enough to encounter the edges of that design. Those edges were always there. They were simply rarely reached. Over extended time, living longer also changes how meaning is attached to survival. When life was short, existence was measured in continuation rather than duration. Success meant leaving descendants and passing on workable knowledge. Modern longevity shifts attention inward. Survival becomes personal, prolonged, and reflective. Individuals now experience the slow unraveling of systems that were never designed to remain synchronized for so long. This experience can feel confusing because it lacks a clear evolutionary purpose. Bodies persist without a defined role once reproduction and transmission are complete. Evolution never assigned meaning to this phase because it was rarely reached. Modern humans now inhabit it routinely. This reveals another dimension of mismatch. Extended life creates space without instruction. Biological priorities end early, but life continues. Individuals must construct meaning in a period that biology did not prepare for. This condition is new in human history. For most of the species' existence, life ended before such questions could arise widely. The long existence of humanity did not depend on resolving this tension. It depended on moving past it quickly. Modern life slows that movement. This slowing exposes how survival and purpose were once aligned by necessity. When survival demanded constant action, meaning followed naturally from participation. Extended safety dissolves that alignment. The body continues, but without clear evolutionary direction. This can make aging feel empty or burdensome rather than simply terminal. Yet this experience does not threaten the species. It only alters how individuals inhabit time. The species remains present because it never relied on late-life coherence. It relied on renewal. Modern longevity adds a long tail to life without changing the structure that sustains existence. This tail must be navigated culturally rather than biologically. Societies invent roles, narratives, and values to fill it. These inventions vary widely because no evolutionary template exists. Variation is expected. Evolution left this space unmarked. The human species existed for so long without needing to define it. Extended life also magnifies awareness of decline. When death arrives quickly, decline is brief. When death is delayed, decline stretches. This stretching makes limits visible and unavoidable. Yet those limits do not indicate failure. They indicate boundaries that were never meant to be crossed repeatedly. Modern humans now cross them routinely. This crossing changes experience, but not survival at the species level. The distinction matters. Humanity endured for hundreds of thousands of years by meeting minimal requirements again and again. Extended life asks for something else: sustained function, coherence, and meaning beyond necessity. Evolution did not supply these because they were not required. Modern culture attempts to. Peace Day. Too near. Success varies. This does not undermine the long existence of the species. It highlights its original efficiency. Humans lasted because they did not ask bodies to do more than they needed to. Modern life asks for more and must compensate accordingly. This compensation is ongoing and incomplete. It operates through social structures rather than biological redesign. Understanding this clarifies why modern aging feels complex, while ancient survival was simple. Simplicity supported endurance. Complexity accompanies extension. The species persists under both, but for different reasons. Its long existence was secured by renewal and flexibility, not by prolonged individual experience. Modern longevity adds depth without adding foundation. It stretches life into spaces evolution never mapped. Those spaces are now filled by culture, reflection, and care rather than biology. This marks a profound shift in how humans live, but not in why they continue to exist. The species remains because its core survival strategy does not depend on how long any one life lasts. It depends on continuation beyond them. Across the entire span of human history, a consistent pattern emerges beneath all surface change. The species endured not by protecting individuals, but by allowing individuals to be lost without interrupting continuity. This principle becomes clearest when all earlier threads are held together. Short lives, early reproduction, constant replacement, environmental danger, cultural learning, and generalist bodies all point to the same conclusion. Human survival was never organized around preservation. It was organized around persistence through turnover. Individuals mattered deeply to one another, but they were not structurally necessary to the continuation of the species. This distinction shaped everything that followed. A system built this way does not collapse when lives end. It absorbs loss and moves forward. The human species learned to exist without relying on stability at the level of the body. Instead, it relied on patterns that could restart. Birth replaced death. Learning replaced memory. Adaptation replaced durability. Each generation stepped briefly into the world, carried the pattern forward, and then exited. Nothing essential needed to remain intact for very long. This design reduced the risk of extinction under unpredictable conditions. When environments shifted or populations disappeared, the species did not depend on preserving what was already there. It depended on beginning again somewhere else. This ability to begin again was the true source of long existence. Many species fail because they become too dependent on specific conditions or specific forms. Humans avoided that dependence. Bodies remained flexible but incomplete. Lifespans remained short but sufficient. Culture remained transmissible but imperfect. None of these features aimed at perfection. Together, they aimed at continuity. This continuity did not require long lives, strong bodies, or stable environments. It required only that life kept arriving. From an evolutionary perspective, this was enough. The human species existed for so long because it accepted limits rather than overcoming them. It did not attempt to defeat aging, injury, or death. It worked around them. Loss was treated as expected, not exceptional. This expectation allowed survival strategies to remain simple and repeatable. Over deep time, simplicity proved powerful. Modern humans often interpret survival through the lens of preservation. Health is protected, longevity is extended, and decline is resisted. These values reflect recent conditions rather than ancient necessity. They do not explain why the species lasted. They describe how individuals now experience time. The long existence of humanity rests on a different logic. It rests on replaceability without collapse. Each life was meaningful locally but optional structurally. This idea can feel uncomfortable because it conflicts with how individuals understand their own importance. Yet it clarifies the evolutionary record. The species did not survive by keeping anyone alive indefinitely. It survived by ensuring that no ending stopped the next beginning. This perspective reframes human endurance. It was not built on strength or foresight. It was built on repetition. Over hundreds of thousands of years, repetition proved reliable. Even when knowledge was lost, it could be rediscovered. Even when populations vanished, others persisted. Even when bodies failed, new ones arrived. The pattern held because it did not depend on exceptions. It depended on averages. Enough survived, enough reproduced, enough learned, enough adapted. That was sufficient. This logic also explains why the human species remains present today despite profound change. Modern conditions differ radically from those of the past, yet the underlying mechanism persists. Continuity still depends on renewal. Individuals still arrive and depart. Culture still carries what bodies cannot. Longevity has increased, but it is not the foundation of survival. It is an addition layered onto an older structure. The structure itself remains unchanged. Understanding this prepares the ground for the final reflection. If the human species existed for so long without preserving individuals, what does that imply about how survival truly works, and what it was never meant to protect? Across this understanding, a quieter implication begins to surface about what survival was never designed to guarantee. If endurance depended on renewal rather than preservation, then much of what modern humans struggle to protect was never part of the original contract. Comfort, coherence, and continuity of experience were not requirements. Survival asked only for repetition that did not break. Everything else remained optional. This explains why so many aspects of human life feel provisional. Bodies deteriorate. Memory fades. Knowledge must be relearned. Relationships end. None of these outcomes threaten existence at the species level. They threaten individual continuity, not collective persistence. Evolution prioritized the latter. This priority shaped a world where meaning was often local and temporary. What mattered was that life continued somewhere, not that it continued in the same form or with the same people. This structure allowed humanity to pass through extreme instability without collapsing. It also meant that survival carried no promise of fulfillment beyond necessity. Once the requirements were met, the system moved on. Modern humans often experience this as absence rather than design. Extended life creates time that biology never needed to fill. In earlier conditions, that time rarely existed. Death arrived before unresolved questions accumulated. Today, safety allows those questions to linger. Individuals live long enough to feel the gap between continuation and purpose. This gap is not a flaw in survival strategy. It is a side effect of exceeding it. The human species existed for so long because it did not require meaning to persist. It required only repetition. Meaning, when it emerged, was constructed culturally and situationally. It could be lost and rebuilt without threatening existence. This flexibility allowed survival to remain simple even as life became complex. It also explains why no single narrative defines what later life should be. Evolution never provided one. It did not need to. The species did not depend on late life roles, sustained identity, or prolonged coherence. Those concerns arise only when life extends beyond biological necessity. Culture attempts to answer them, but answers vary because no evolutionary template exists. This variation is not failure. It reflects freedom from constraint. Survival did not prescribe how extended life should be lived. It only ensured that life would continue. This understanding reframes modern anxiety about aging and decline. These experiences feel unsettling because they expose the limits of a system optimized for something else. Yet they do not undermine endurance. Humanity remains present because its survival does not hinge on resolving these tensions. It hinges on renewal continuing. Even in a world of long lives, that renewal persists. Children are born. Learning spreads. Adaptation continues. The underlying mechanism remains intact. Extended life changes texture, not structure. It deepens experience without redefining survival. Recognizing this can soften expectations placed on the body and on time. Longevity does not need to deliver coherence because it was never designed to. Survival did not aim to protect experience indefinitely. It aimed to allow existence to continue, despite loss. That aim was met repeatedly across deep time. Modern humans now live with the consequences of exceeding that aim. Those consequences are real, but they are not threats to the species. They are challenges of living beyond necessity. This perspective invites a final reflection. If survival was achieved without preservation, then the value of extended life may lie not in resisting limits, but in how individuals choose to inhabit the space those limits leave behind. Evolution secured existence. It did not dictate what to do with the time that followed. That responsibility now belongs elsewhere, beyond biology. It belongs to culture, reflection, and choice. The human species endured by moving forward without waiting. Modern humans now have the rare opportunity to wait, to observe, and to ask what survival never needed to answer. That opportunity changes experience, not existence. Continuity remains. Renewal continues. The long presence of humanity stands as evidence that survival does not require completion. It requires only that life keeps arriving. Everything beyond that is open. Across all the paths traced so far, a final clarity emerges about what the long existence of the human species truly rests upon. Survival, as evolution shaped it, was never meant to preserve moments, identities, or bodies indefinitely. It was meant to keep life moving forward despite loss. That movement did not require completion, it required continuation. Once this is understood, the long arc of human history appears less mysterious. Humans did not endure by mastering time. They endured by accepting its passage. Lives began, contributed briefly, and ended, while the pattern continued. Nothing needed to be held forever. What mattered was that something arrived next. This design produced a species capable of surviving immense instability. When environments shifted, when knowledge vanished, when populations collapsed, the species did not wait to recover what was lost. It moved on. That movement was enough. Modern humans often feel tension with this truth because extended life invites different expectations. Living longer creates space for memory, attachment, and reflection. These experiences are meaningful, but they were never required for survival. Evolution did not optimize for them. It optimized for repetition that did not break. The result is a body and a species that can exist for a very long time without offering guarantees about how that existence should feel. This absence of guarantees is not an error. It is a consequence of a system built for endurance rather than fulfillment. When viewed through this lens, the question of why the human species has existed for so long becomes less about exceptional traits and more about modest requirements. Humans did not need to be perfect, durable, or complete. They needed only to be sufficient, again and again. Enough survived, enough learned, enough adapted, enough reproduced. That was enough. Everything else was optional. This simplicity explains both the strength and the fragility of the human condition. Strength lies in resilience to loss. Fragility lies in the lack of promises beyond survival. Modern life amplifies this fragility by extending time without changing the underlying logic. Individuals now live long enough to encounter questions survival never needed to answer. What should remain? What should be preserved? What should endure within a single life? Evolution remains silent on these matters. It has already done its work. The species is here. The rest is undecided. This understanding carries a quiet lesson. The long existence of humanity was secured without clinging. It was secured through letting go. Bodies were allowed to fade. Knowledge was allowed to fragment. Groups were allowed to disappear. Continuity emerged not from preservation, but from renewal. This renewal did not erase meaning. It left meaning to be constructed locally, temporarily, and repeatedly. That construction is now a human responsibility rather than a biological one. Survival provided the opportunity, not the instruction. At the end of this long reflection, the central question remains open. If existence was secured without preserving lives, memories, or identities, then what does it mean to live within the time that survival never needed to protect?